Okay, so find the probability. A basic idea is separation. We just separate all into parts, like into this. Okay, like this part, this part. Then we can have those questions like, what is the probability? Like, are we from say from all pick some? So what is the probability? Just come from this part or come from this part, right? Okay. So now let's consider the problem. It says a box contains 5 cards numbered 1, 2, 3, 4, 5. So from here we just pick 3. Like, okay, we have 1, 2, 3, 4, 5. So from here pick 3 cards. Okay, we just pick 3 cards randomly. So without replacement, so we pick one by one by one. So what is the probability that 4 is largest value? So we just split those numbers into 2 parts. This less than 4 and equal 4, or actually larger than 4. So we just split into these 3 parts. Okay. So totally, how many ways? We say from 5 pick 3. So in order to guarantee that this 4 is the largest, so from here, so we should pick 4, right? Make sure that's the largest. So from this part, pick 1. From only 1, pick 1. Then from here, pick 2, right? So from the 3 total 3 numbers, just pick 2. Okay. So the probability is this. So here we can understand this is so here from total pick 3, we don't care which 3 we picked. Then split this into parts. From this part pick 1, from that part pick 2, and from this part we also can say that from this part pick 0, but from this part pick 0, from this part pick 0, we define this equal 1, or in general from n pick 0, that's equal 1. So we can consider from this part pick how many, from that part pick how many, just like that. So we can say like totally the 1, 2 equals 3, right? Okay. So here we want to find. Okay, so this is like from here pick 2. We say 2 different numbers are selected from this. From here pick 2 numbers and then multiply together. So what is the probability that the result is 0? So if the result is 0, so this means 0 multiply some other numbers. So we just separate those numbers into 2 parts, 0 or not 0. So not 0, okay, -2, -1, 3, 4, 5. So we just split this into 2 parts. Okay. So from here pick 2. So totally how many ways? We say from 6 numbers we just pick 2 randomly. So we have totally so many ways. So in order to guarantee that the product is 0, so this means from this part we should pick 1, and then from this part we need to pick another 1, right? So from this part we have only 1 number. From this 1 number pick 1. From this part totally 5, pick 1. Okay. So this number equals 5 choose 1, pick 1, 5. 6 pick 2, so this is 6. Let's say for this number equals multiply two numbers like here 6 5 1 2, okay, 15, right? Okay, so this is 1 over 3. Okay. Okay, so here we want to actually pick 3 numbers. Select 3 numbers from here. And we want to guarantee that the sum of these 3 numbers is even. So we can like find how many ways or how many subsets. Okay. So here we're talking about even odd. So we just split those numbers into 2 parts: even number or odd number. So even 132, 166, even, right? And then odd number or 89, 95, 99, and 173. Okay, so we just split this into the 2 parts. Okay, so pick 3. Okay, so the question is how many ways. So we set the sum of the 3 numbers even. Okay, so 3 number. So we have 2 even then plus 1 plus odd is this odd. So only case is just the odd plus odd thing plus even, right? We cannot pick 3 odd. Odd plus odd plus odd is this odd, right? So only is just this way. So this means from here we need to pick 2. From here, pick 1. So how many such ways? So from this 4, pick 2. So 4, pick 2. And then from this 1, pick. From this 2, pick 1. Okay. So this equal, I think, is 12. Okay. So sometimes we find a probability, we just check all case by case. Or this case, then we just count how many cases. Okay. So for this problem, let's say a fair 6-sided die is loaded twice. So this die is just like this, right? Here 1 point, here 2, 3, like those die. So if we load this die twice, so first one can be like 1 2 3 4 5 6. Second one also could be 1 2 3 4 5 6. So the question is, what is the probability that the first number is greater than or equal to the second number? Okay, so for those problems, we can say like if first one is 1 1, so we can say 1 1. Or if first one is 2, so 2 1 2 2. If first is 3, we said 1 case, not 2 case. And the first is 3, so 3-1, 3-2, 3-3, and if the first one is 6, so 6-1, 6-2, 6-6. So we can find totally how many of those cases. We see this 1 plus 2 plus this 1 case, 2 cases, 3 cases, and just a plus 4 plus 5 plus 6. And so totally how many cases? So this 6, right? So for other ways, we can, let's say, so we suppose this the first one is x, second one the number is y. So we have these 3 cases: x larger than y, or x less than y, or x equal y, right? Okay. So let's say that we can find those probabilities. Suppose so this probability is probably same. So we suppose this probability x larger than y is p, then this is also p. Because x larger than y, y larger than x, this is symmetric, and we just need to find this case probability. So x equal y is 1, 1, 2, 2, 3, 3, like so. We have only 6 cases. So 6 over 36. So this equal 1. So we can find this p. So 2p plus 1 over 6 equal 1. So we can find a p. But what we needed to find is just p plus 1 over 6, right? So this equal what? So we can find the p. Let's say we also can use this with a p to p equal 1 minus 1 over 6. 1 over 6 is 5 over 6. So p equal 5 or 12. Okay. So answer, let's say answer. So this probability actually exactly like x first one larger than second one. Yeah. This equals this. So the our question is could be larger than, greater than, or equal. So here we have 2 cases, right? Equal. This case or equal. So answer is equal larger than plus equals equals 1 over 6. So this equal 12, and here is 5 plus 2, 7. Okay. So do we have this answer 7 over 12? Yeah, oh, we have. Yeah, so this one, right? This should be our answer. Okay. Okay. So now let's check some examples. Okay. Let's consider this one. It says a top hat contains 3 lead chips and 2 green ones. So here we have 3 lead one and 2 green one. Okay. Okay. So chips are drawn randomly, one at a time without displacement. So until all three of the lead are drawn, or until both green chips are drawn. So let's say, so here draw, so could be like R, G, then we can stop, right? Yeah, in this case, stop. So could be R, stop. So R, G, R, we need to continue, right? We need to continue. So let's say could G, so stop here. So or could be R, G, R, stop. Okay, so the question is, what is the probability that the 3 LED are drawn? So not this case. That was the probability this case happen, not this case. Like this case happen. So we want to find the probability for those cases. Okay. Okay. So now let's say if we want to guarantee we have 3 LED, we get a 3 LED. When we stop there, we get a 3 LED. So we can only have 2 cases. One case is first LED 1, second LED 1, third LED 1, right? So what is this probability? So such a probability we say equal first one LED 1. So from here pick one. First one LED 1 is we have 5. So we have 3. Then second one is we pick another LED 1. So 4. So we have 2, right? And 3, 1. So first one LED 1, second one LED 1, third one LED 1. Okay. Okay, and also so could be like we pick like R, G, R, like those. So we also can consider like here we need a 3 draw. We need a 3 and we need a 4. So could be this, could be this, like could be G, so R, right? Or just let's say so here, so actually we have 4 cases, right? Could be like we can put a G. Oh no. 3 like cannot be this, right? Oh, so then we don't need to draw. So could be like let's say R, yeah, could be R, G, R. So we have those 3 cases. So let's check what is this probability RGRR. So RGR probability 3. First one is R. Second one is G. So here we have 2G. Okay. 31 is another R. So we picked one R LED 1, so we have 2 LED 1 left, and the first one is R. So by now we just have one R, one G, so just 1, right? Okay, and this one G, let's say G is 5, 2. Then R, so 4, so 3, 2, I think is 1. So those we find those 3 probably the same. So this we put this as P1, then this case P2 is just equal 3 over 5, 2 over 4, 2 over 3, 1 over 2, multiply 3 cases, like 3. Okay, So if we pick 5, we should pick 5. Pick 5. We have no such case. Like pick 5, we already have this 3. We don't need to pick 5 to get this 3. So let's say if we put R here, like G R G, then we stop here, right? We stop here, so this thing cannot happen. Okay. Okay, so we just have this P1 plus P2. So let's check the answer. Okay, so this equal P1 equal cancel this 3, cancel this 2, 1 over 10, right? So P1 is 1 over 10. So what is the P2? P2, let's check this. P2 equal, we say cancel this 2, cancel this 3. So this equal, and cancel this. This equal 6 over 10. Yeah, 6. Oh no, no. Let's say. So here, 1, 2, 2. 3 over 10. 3 over 10. So total is 4 over 10. 4 over 10. Okay, 4 over 10 is 2 over 5. Okay. Okay, so this problem, it just says the license plate have 4 symbols. The first one must be just from this 5 pick 1. The second and third must be 2 different letters among the 21 non-vowels. And the first one should be, so we just check one by one. So first one have 5 choices, right? So second one we have must be 2. Okay, so here is must be 2 different letters from the 21. So here this one can be 21 choice. Then those cannot be same, so this should be 20, right? And the first one must be digit 0 through 9. So we have 10. Okay, so this is total ways. Okay, so the probability, the question, what is the probability that the place will lead AMC8? So AMC8, if we say AMC is only one case, like first one should be A, second one should be M, third one should be C, should be 8. So this equals just 1 over this, 1 over 5 times 21 times 20 times 10. So this equal, we say this times this 200. 100, so here 1,000, 1,000. So this is just 20,000, 21,000. Yeah. Okay, this problem says baseball league consists of 2 4-team divisions. So 4 team division. So we have like the team. Here we have 2 4 team. Okay, like that, like 4 team, 2 4 team. With 4 team, we have 2 4 team. Okay, so each team play every other team in its division in games. So for this one, let's say for this one, you play says this in games. So okay, play others in games. Okay, so here totally how many games we need to play. So let's say, so we do not count total. Okay, and each team play every team in the other division. So other division in games. So with the games n, suppose n equal like 4. So these 2 need to play 4, these 2 need to play 4, like that, right? And so this one play this one, different other let's say. Other division, like here's division 1, like let's say we say there's a division, there's another division. So for those 2, let's say for those 2 need to play in games. So it says each team plays a 76 game schedule. So let's focus on this team. Suppose this team is A. We just check. So this is team A. A, B. So each team need to play a 76 game. So what we need to find. We need to find how many games does the team play within its own division. So this is just n. We need to find n equal which number. Okay, so for this team A, how many times he should play it? So this team should play with each team. So here, with other teams within division. So we say should play n with this n. So need 3n, right? And then this team play other one need 4 of them, right? So for each one m. So here 4m. Okay. So we say this equal 76. So from here, so we need to find what is n. Okay. So such a problem is just solving integer equations. Okay. Okay. So let's say here this is multiple of 4. The 76 also multiple 76 is multiple of 4. Okay, so we say this n should be 4k, a multiple of 4, because other two is multiple of 4, right? Okay, so we replace this, so divided by 4, so we say 3k plus a equal 19. or we say so 19. So oh so what is the k? So here m is larger than 4. So we just m equal 5. Okay, m equal so we say so we just check m equal 5, m equal 6, just like that. So here so we say 19 minus m should equal 3k, right? Should equal 3k. So 3k, so could it be, so we just check, could it be 18, most of the large 18 and 15 like that, right? And 12 or 19, 9 or 6, 3. Okay, so we can find this m. Let's say so m, so if this equal 18, m equal 1, so but m is at least 4, so cancel this. M this 19 minus m equal 15, so this m equal 4, cancel. Okay, so now that is the case. So so we just check how about it. So 12, 9, 6, 3. So if 19 minus m, so we just put this like, okay. If 19 minus m, so we can find m. Yeah. So if m 19 minus m equals 12, m equals 7, right? M equals 7, or if 19 minus m equal 9, 19 minus m equal 9, then m equal 10, like that. M equal 10, or so m equal, could it be 13, and it could be 16. Okay. So from this m, so we can find k. Let's say, so here we just check those cases. Like if let's say, so we put m and k, then m. So let's say m equals 7. What is k? M equals 7. So 19 minus m equals 3k. So k, 3k is 12. So k equals 4. And this is then n equal, we said n equal 4k. So n equal 16. Okay, so then we just check how about m equal 10. M equal 10. M equal 10. Then k equal 3. Yeah, k equals 3. Okay. Like 19 minus m equal 9. So m equal 10. And 9 is 3k, so k equals 3. Yeah. So then n equal 12. Okay. So actually, so we have several of those. We have those solutions. So we just check which one. Okay. So we need this condition: n larger than 2m. N larger than 2m. So this one okay, but this one not okay, right? So our answer is this case. M is 7, n equals 16. Okay. So we say m equals 7, n equals 16. So how many games does the team play with its odd division? With its odd division, you need to multiply by 3. Yes, the answer is not, the question not n, actually we want to find 3n. Okay, so the answer by now n equals 16, so 3n is 40. Okay. So this such a problem is a little bit tough. We need to consider case by case. Yeah. Okay. We should stop here. Okay. So we will continue. Let's see.